Hi guys, today's lesson is about transformation of trig functions. So we have talked about transformation of other functions from quadratic, cubic, all other kinds of function. Now we're going to look at the transformations of the trigonometric functions. So as in the quadratic and the other kind of functions, we had a, k, d, and c as our parameters, and then we changed the a, k, d, and c, and that will transform our function. So as in the other functions, a gave us a vertical stretch or a vertical compression. And also, if it's negative, then it gives us a reflection in the x-axis. So that would be the same with respect to trig functions. So if I have an a value and the a value is greater than 1, and then I will have a vertical stretch. If the a value is between 0 and 1, then I have a vertical compression. And if a is less than 0, so it's negative, it should be it's negative, then you have a vertical reflection, not a reflection in the x-axis. Now, something that you also have to add to this is that the a value, so if I go here and I show you this decimals. If you look at, I'm going to start a at 1. And so this is a at 1 with no transformation with respect to the a. If I change the a, right, it's going to cause a vertical stretch and a vertical compression. But what you can see is that as I change a, right, I have a vertical stretch here, but also that represents the amplitude. So if I have, just to remind you that the amplitude is from the axis of the sinusoidal function to the max. So let me just show you this. So in this case, this here is the amplitude, right? Because the axis, which is the middle here, is the y equals 0. And then my amplitude in this case is 2. If I go back here and change the a back to 1, you see that the amplitude here is 1, right? So you see that the amplitude is 1, but when I change a to 2, the amplitude is going to become 2. If I change it to 3, the amplitude is going to be 3. So the a value tells you what the amplitude is. Remember that the amplitude is always going to be a positive value, so it's going to always, you're going to look at the positive value of it. You can always measure it. You can also measure it from the x-axis down to the, or from your axis down to the minimum, but remember that you always state it as a positive value, as an absolute value. So your amplitude in this case is 3. If your a value is negative, still you're going to have to report your amplitude as a positive value, and then in this case, so if I'm going to find the amplitude here is 3. All right, even though my a value is negative 3, the amplitude is the absolute value of a, which is in this case it's 3. All right, so let's go back here. Now k is, as we have seen before, k gives me a horizontal stretch or compression by a factor of 1 over k. So if k is greater, let's put it in absolute value. If k is greater than 1, then I have a horizontal compression by a factor of 1 over k. And then if k is between 0 and 1, then I have a horizontal stretch by a factor by 1 over k. Okay, so so remember that, and then k represents, so it tells you what the period is, and to find the period you do 2 pi over k. All right, so let's say if k is 4, right? To find your period, you do 2 pi over 4, and that's going to be pi over 2, and then that will be the period of your function. If k is negative, then we have what we call a horizontal reflection or a reflection in the y-axis. So let's go back here and let's look at, so let me erase this. And let's look at what happens if I change k. So what first I'm going to do is I'm going to set this equal to 1. All right, now we're going to change k. Okay, so let's say if k is equal to 2. Okay, so you see that I have a horizontal compression. So I'm compressing it. It's going to look smaller, right? So if you look at this right here, so I have, this is a whole, one whole period, right? So before, when k was equal to 1, see, I'm going to draw this one in a different color so you can compare the two. So the normal, that's not 1. Okay, just 1 second. Let me erase this. Okay, let me change that back to 1. Come on. So when k is 1, right? When k is 2, so I have a vertical, horizontal compression. Now here is my new function. So you see that's half of my original one. Okay, so I had a horizontal compression. If k is less than 1, so it's between 0 and 1. So let's look at it as, for example, 0.5, right? So you see that right now, what I have here is I have a horizontal stretch, okay? It looks wider. So I have a horizontal stretch if k is between 0 and 1, and then it's gonna look much bigger. All right, so you can use this Desmos to explore further. All right, now D is going to shift to the right or shift to the left. So if D is greater than 0, what you're going to see in the function, you're going to see a negative value. So let's say if D is equal to pi over 2, right? So you're going to see as sine x minus pi over 2, okay? So that means D is positive. And it's going to be horizontal shift to the right pi over 2. If D is negative or less than 0, you have a shift to the left and it will look like this. So sine x plus pi over 2. C will give you a vertical shift, so up and down. You guys can use the Desmos to look at it, and then if C is positive, then you have shift up. C is negative, then you have a shift down. Okay, so that C will change. So if you're looking at C, I'm going to set this back to 1. I'm going to erase this. All right, so if you're looking at C and if you're changing C, you're going to see that your axis is going to change. So, so I'm going to keep D as 0 and I'm going to change C. So it's going to bring up your graph up or down. In this case, C is equal to 2, for example. And now my axis, so if you look here, my axis is at 2 now. Okay, it's not at 0 anymore. So C determines what your axis is. All right, so all right, so if I have a function that looks like this, y equals 3 sine half theta plus pi over 3 minus 1. State the amplitude, period, all of these. So the amplitude, it's easy. It's whatever A is, so it's the absolute value of A. And in this case, so the amplitude is equal to the absolute value of A, and in this case, it's equal to 3. To find the period, you're going to have to do 2 pi over K. So in this case, it's going to be 2 pi over a half, which is equal to 4 pi. Phase shift, so we're looking at this. This is my phase shift, and then since it's positive here, that means it's negative. So that means I have a phase shift negative pi over 3 or shift left pi over 3. Vertical shift, so I have, this is my vertical shift, and then in this case I have a vertical shift up, or down, sorry, because it's negative 1. Now to find the max, there is a formula for that, and then to find the max, what you're going to do, you're going to take the C value, and then you're going to add the amplitude. Okay, so C plus A gives you the max. So in this case, negative 1 plus 3, that gives me 2, and that is my max. To find the min, so it's going to be C minus the amplitude. So in this case, it's negative 1 minus 3, which equals to negative 4. So my max is 2 and my min is negative 4. Okay, so I'm going to take this to Desmos and I'm going to try to graph this function in Desmos, and let's see if we can see all of this. All right, so we said that A is equal to 3. Let's see if I can do that. So A is 3. K is a half. C is negative 1. And D is pi over 3. So let's see if we can do that. Or it's negative, sorry. There you go. All right, so so in this case, the axis is at negative 1. Okay, the maximum was at 2. I'm looking at the amplitude from negative 1 to 2, that's 3. My min is at negative 4. And the period is, so if you're looking at a period, I have a pi over 3 shift to the left. So that's 60 degrees to the left. Okay. And then this is where it's starting right here. And then it's ending at, in this case, it's ending at about 660. Or 6. See if I can find that value here. I don't think I can find it. All right, so this is how the graph is going to look like with all the transformation. All right. So the next question is asking to graph y equals 2 sine 2x minus pi over 3 plus 1 using transformation, then state the amplitude and period of the function. So we're going to start with, so we're going to use the mapping notation here. And then we're going to start with the original function, so y equals sine x. So if I have x equals 0, pi over 2, pi, 3 pi over 2, and 2 pi. So at x equals 0, y equals 0. At x equals pi over 2, y equals 1. At x equals 2 pi, so sine of pi is 0. So sine 3 pi over 2 is -1, and sine of 2 pi is 0. So this is my original function, and I'm looking at finding the transformation, finding the new points for the new function. And as we've talked about in previous functions, we know that we're going to use the a, k, c, and d to find our new points. And then we talked about you do x divided by k, and then plus or minus d, and then you do a times y plus or minus c. Okay, so in this case it's going to be x divided by 2 because k is 2, and then because it's to the right pi over 3, I'm going to add pi over 3, and then for the y values it's going to be 2 times y plus 1. Okay, so remember this mapping transformation. So now what we're going to do, we're going to take the x values, we're going to divide them by 2, and then we're going to add pi over 3. So 0 divided by 2, that's 0 plus pi over 3, so that's going to be pi over 3. Then I'm going to take x, so pi over 2 divided by 2. Just going to do the math here for one side. So pi over 2 divided by 2. So that's going to be pi over 4. And then plus pi over 3. So pi over 4 plus pi over 3, common denominator is 12. Then I have 3 and I have 4. So 3 plus 4, that's 7 pi over 12. Okay, now I'm going to take pi and then divide it by 2 and add pi over 3. So my denominator is 6, and that's going to be 3 pi plus 2 pi, so that's 5 pi over 6. And then I'm going to take 3 pi over 2 divided by 2, so that's going to be 3 pi over 4. And then add pi over 3. So that means I have to have a common denominator of 12. And then that means this is going to be 9 pi plus 4 pi. And that's going to be 13 pi over 12. And last, 2 pi divided by 2 plus pi over 3. So it's going to be pi plus pi over 3. Common denominator is going to be 3, so that's 4 pi over 3. Now, with respect to the y values, I'm going to multiply the y value by 2 and then add 1. 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, plus 1, that's 3. 2 times 0 is 0, plus 1 is 1. 2 times -1, that's -2, plus 1, that's -1. 2 times 0 is 0, plus 1 is 1. So I have now my new points. Now, because my new points are kind of all over the place, I'm gonna have to pick a good scale. Okay, so what I'm going to do is I'm going to just scroll this up. So I usually take, personally, that's what I would do. I usually take the one with the biggest denominator, and I make it as my scale. So that means this is going to be over 12, right? So that means I'm going to have to go by pi over 12, okay? So that's going to be 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, 6, 7, 8, 9, 10, 11, 12, and then I can add 1 to 13. Now, that being said, I'm going to be missing some points, okay? But it won't fit on this graph. So 3 pi over 12, and then we have 4 pi over 12, sorry, 14 pi over 12. And so on, okay? Or we can take it as pi over 6 if you want, so we can do either or. If I do pi over 6, then I have to change all of these to pi over 6, and that means I can do it as 2 pi over 6 and then 3.5 pi over 6, which is gonna give me decimals, which that's why I don't like that. So let's see if I can do pi over 12 here, okay? So pi over 12, 2 pi over 12, so that's pi over 6. 3 pi over 12, so that's pi over 4. 4 pi over 12, so that would be 4 pi over 12. That's going to be pi over 3. 5 pi over 12. 6 pi over 12, which is pi over 2. 7 pi over 12. 8 pi over 12. I can simplify that, divide both of them by 4. So that's going to be 2 pi over 6. No, actually 8 pi over 12. Sorry. If I divide both of them, so it's going to be 2 pi over 3. Nine pi over 12, so I can divide both by 3, so that's 3 pi over 4. 10 pi over 12, we can reduce later if we want, so that's going to be 5 pi over 6. I need to give myself something here. And then, so we got to 10 pi, 11 pi over 12, 12 pi over 12, so that's pi, 13 pi over 12, 14 pi over 12. So if I divide both by 2, so that's going to be 7 pi over 6. 15 pi over 12, I can divide both by 3, so that's going to be 5 pi over 4. So we said 15. 16 pi over 12. And that's going to be 4 pi over 3, and that's the last one that I need. Okay. Now, again, you could have picked a different scale. This scale, I usually like to pick the smallest denominator that I have and go up by pi over whatever that denominator is. That's the way I like to graph it. Now, my first point is going to be at pi over 3, 1. So it's going to be, so let's go 1, 2, 3, and then negative 1. And then it's going to be at pi over 3, 1. And then I have 7 pi over 12 and 3. Then I have 5 pi over 6 and 1. Then I have 13 pi over 12 and negative 1. And then I have 4 pi over 3 and 1. And that is going to be my, there you go. To the best of my ability, graphing on a computer like that. All right. So you can extend it to the left and to the right. Okay, mostly to the left here, but this is how I personally would graph it. All right, if you have any other way or a better way, you can do that. I like to see all my points. Now you could have skipped some of the points, but then this is like you could have skipped writing as long as you know what they are. Okay. Now, given a graph, how can you find the equation? So given the graph, you're gonna find A, K, D, and C. So you must find all of these to be able to find the equation. So to find A, you're gonna have to find the amplitude. And the amplitude is equal to the max minus the min divided by 2. Okay, so to find the A value, you just have to find the max, the min, subtract them and divide by 2. To find the K value, so you're going to find the periods in radians of a function using a starting point and end point of a full cycle. And then to find K, you're going to do 2 pi over the period. And that will give you K. So you're going to find your cycle. Remember that sine starts at the axis and then goes up and then go down and come back to the axis. Okay. And cosine starts at the max, go down, and then go back up to the max. So that's a full period for cosine. Okay. And a full period for sine would be starting at the axis, go up, and then come back to the axis. That would be a full period. Now, if you're starting at the min for cosine and go back to the min, then your A value is going to be negative. Now, I'm going to move to the C, so the vertical shift. To find the vertical shift, you can do two different, so the vertical shift would be basically your axis here, okay? And to find that, what you can do, there's two things you can do. So you can do max minus the amplitude, or you can do max plus min divided by 2. Okay, and that will give you the axis, which is the middle of the function. Now, the x coordinate and the d value, basically. So what you're going to do, you're going to have to find your shift. Okay, so let's say, where are you going to start? Okay, once you find your axis, then you're going to label your axis, and then you're going to say, okay, I'm starting here, because d value can be different for all of us. Okay, let's say we decide to start here, or we decide to start here, or we decide to start here, or we decide to start here. So it depends on where we decide to start, then D would be. Okay, so that's why there is no one answer for D. There are multiple answers for D. So it all depends on where do you decide to start your function. Okay, now, so let's look at this graph here, and let's determine the equation of the sine cosine function that describes the following graph. So they want the sine and the cosine. So the first thing I need to find is the max. So, and then to find the amplitude. And to find the amplitude, what I need to locate is the max and the min. So the max is at 2, the min is at -4. So to find the A, which is the amplitude, I have to do max minus min divided by 2. And that's going to be 2 minus -4 divided by 2. And that equals to 2 plus 4, that's 6. 6 divided by 2, that is 3. So the amplitude is 3. All right, now to find K, so remember that K is the period, and that means if I'm starting, so the easiest way to find the period is to actually start from a max to a max. That's the easiest if both are visible. And then basically in this case, this is the period here. Okay, and it's starting at, this is pi over 4, 2 pi over 4, 3 pi over 4. So starting at -3 pi over 4. and it's going all the way to, so this is 3 pi over 4, 4 pi over 4, 5 pi over 4. Okay, so this here is 5 pi over 4, and this here is negative 3 pi over 4. So the period is from negative 3 pi over 4 to 5 pi over 4. So period is 5 pi over 4 minus negative 3 pi over 4. So always to find the period, you find the maximum, like the last value, and then you subtract it from the first value, and that's going to be 5 pi over 4 plus 3 pi over 4, so that's going to be 8 pi over 4, which is equivalent to 2 pi. Okay, now to find the k value is 2 pi over the period, and that's going to be 2 pi over 2 pi, so k equals 1. All right, to find c, so to find c is equal to max minus the amplitude, or minus a. So in this case, it's going to be the max, which is 2, minus 3, and that's going to be negative 1. So this is telling me that the c value, or my axis, is right here at negative 1. Okay, now sine starts at the axis. So I can choose to start my function right here, or I can choose to start it right here, or right here, or right here is not a good idea because that's the end of it, okay? But I can choose to start it at any of these points, okay? So that's, we're talking about the sine, okay? So let's say if I choose to start it right here, I'm just gonna pick a different color. If I choose to start it right here, I have to be careful that it's going down and then back up. So that means my a value is gonna be negative, okay? If I choose to start it right here, it's going up and then it's going down. So the a value is gonna be positive, okay? So you have to be careful with this. So let's say I choose to start right here. I can choose whatever I want, one of these points. So then my function, so d is going to be, in this case, 3 pi over 4. And then my function is going to be y equals, the a value is 3, so it's going to be 3. And sine k is 1, so I don't need to include k. And then it's going to be x minus, and because I moved 3 pi over 4 to the right, it's going to be minus 3 pi over 4. And then take away 1 for c. For cosine, you're going to have to pick to start at a max or at a min. So let's say if I picked here for cosine, okay, so that is going to be, so y equals 3 sine, again, because I'm starting at the max, then it's going to be positive. And then, sorry, it's going to be cosine. And then x, and then it's going to be negative 3 pi over 4 to the left, so that's going to be plus 3 pi over 4 minus 1. Okay, so choosing where you want to start your function, that will decide what d is. But remember that if you have a reflection, then you have to make sure that your a is reflecting that as with a negative value. Okay, you can try the next question. What I'm going to do is I will give you the answer to this question, but remember the next question has values of, actually let's do it together, -1. because it's a little bit different. All right, so max to max, so that means I'm looking for the period. My max is at 3 and the min is at -5. So that means the value is going to be max minus min divided by 2. So that's going to be 3 minus -5 divided by 2, and that's going to equal to 4. So A equals to 4. If I'm starting at 20 and ending at 60, so that means the period is 60 minus 20, which is 40. Okay, and then to find the K value, you do 2 pi over the period, and because the period is 40, so it's going to be 2 pi over 40, which is equal to pi over 20. So K is equal to pi over 20. Then to find C is equal to max minus the absolute value of A, which is going to be, the max is 3 minus 4, so that equals to -1. So again, in this case, the C value is at -1. Now, if I'm looking at sine will start at any of these points. So sine could start here, 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 whatever I want it to start, or here if you want. So I'm going to start here, right, which is at 10. So this is D for sine, okay. Cosine is going to start, I'm going to use red. So cosine can start max. It can start at the min, but remember then A is going to be negative, or it's going to start here, okay. So we're going to call this the start of cosine. Doesn't matter which one I pick, no, it does not, remember. So if I'm looking at the sine, the equation of the sine, so the equation of the sine is going to be y equals 4 sine pi over 20 x minus 10, because I moved 10 to the right, minus 1. And if I'm looking at the cosine, it's going to be y equals 4 cos pi over 20 x minus 20. Move 20 to the right, and then take away 1. All right. So create a sine function with an amplitude of 7, a period of pi, a phase shift of pi over 4 to the right, and a vertical displacement of -3. All right, so this is telling me that A is equal to 7. Period of pi, that means K is equal to 2 pi over period. So it's going to be 2 pi over pi, which equals to 2. Phase shift is pi over 4, so that means that gives me D, which is my displacement, pi over 4, and a vertical displacement of -3, so C is equal to -3. And since this is a sine function, then I can write it as y equals 7 sine 2x minus pi over 4. Remember, it's shift to the right, and then -3. So what would be the equation of a cosine function that represents the same graph as the sine function above? So in order for me to find that, so I'm going to take you back to the previous page, show you this. So if you're looking between the two functions, all right, what you're going to do, if you know what d sine is, then to find the d of sine, if you know what d of cosine is, you do d of cosine minus pi over 2k. That's the formula for it. If you're looking for d of cosine and you know d of sine, then you do d of sine plus pi over 2k. Okay, so this is the formula to find, if you know the d of one, then to find the other one. Let me go back here. I know d of sine, so to find d of cosine, that's going to be d of sine plus pi over 2k. So d of sine is pi over 4, and then plus pi over 2 times 2. So in this case, pi over 4 plus pi over 4, and that's going to be 2 pi over 4 or pi over 2. Okay, so I found d of cosine. Everything else is going to be exactly the same. A, k, and c are going to be exactly the same. So my function is going to be y equals 7 cosine 2 x minus pi over 2 minus 3. All right. And last thing we're going to look at today is even and odd function. So remember that we talked about even and odd functions, and we said that an even function will have a line of symmetry over the y-axis. And odd function if it's an odd function if you have a point of symmetry about the origin, and that's 0, 0. Okay, and remember that in this case y equals x squared or 2x or x squared plus 2 or whatever this is. It has a line of symmetry, the y-axis, and this has a point of symmetry at the origin. Okay, and we talked about the rule f of negative x equals to f of x. That means it's an even function. And then negative f of x equals to f of negative x. That means it's an odd function. We talked about that before Marshall break. All right, so let's look at cosine and sine functions. Are they even or are they odd? So if I'm looking at the cosine function, you see that there's a line of symmetry at the y equals 0, at the y-axis, at the x equals 0, sorry, at the y-axis. So there is a line of symmetry. So that's why cosine x is considered an even function. And the sine function has a point of symmetry at the origin. Okay, so it's symmetrical at the origin. Now let's test it. So let's look at f of pi. F of pi equals 1. Sorry, negative 1. Now, what would be f at negative pi? So if I'm looking at f of pi here, right, it equals to negative 1. And f at negative pi is equal to negative 1, right? If you're looking at f of 2 pi, that's equal to 1. F of negative 2 pi, that equals to 1. Okay, so you're looking at the point and its negative value, and then you're going to see that. So if you're looking at this point here and this point here, right, they're going to have exactly the same value. Okay, and that's what we call a symmetry around the y-axis. So this is telling me here, therefore, f of pi is equal to f of negative pi. All right, which means it's an even function. Now you can't test it with a point, but it works here. Okay, if I'm looking at the sine function and I'm looking at f of pi over 2, f of pi over 2 is equal to 1, and f of negative pi over 2 is equal to negative 1. Okay, so what this is telling me that f of pi over 2 is equal to negative of f of negative pi over 2. right? Or we can write it the other way, which is f of negative pi over 2, which is f of negative x, is equal to negative f of pi over 2. Okay? And the last thing that we're going to talk about, so remember that cos is cos x with no horizontal transformation. So with no d value, if it's not moved to the right d or to the left d, and sine also if it's not moved to the right or to the left, then we can look at cosine as an even function and a sine as an odd function. And then tan x is also an odd function, right? So look at that it's symmetrical. I'll just show you here. So it is symmetrical along the origin. All right, that's it for today's lesson. And then there is one more lesson and we're going to be done the course. So the last day for the course would be Monday next week. And then after that, it will be, I'm going to have to finish marking everything. And then I'll probably give you the last lesson next Monday. And then Wednesday is going to be the last day of the course.